area. Write the area of a circle. Right, let's just stop right there. What is the area of a circle?
Pi r squared.
So this area is expressed in terms of the radius. So that is A. A is done. We've written area in terms of radius. Okay, now we have to write area in terms of diameter. So what do we know about diameter? Diameter is 2 radii.
Yeah.
So R is D over 2. So I can take this and plug it in here. So then area is pi times D over 2 squared, which would be pi times D squared over 4. Now, area is written in terms of diameter. Now, what about circumference? Well, what's circumference?
Pi d times pi.
2 pi r or pi d, whichever one you want to do. So I'm going to go back and just do this. If you want to do pi d, you can. But radius is circumference over 2 pi, or circumference over a diameter. Diameter would be circumference over pi. So since I did it in terms of r, I'm going to plug it in here. So area equals pi times c over 2 pi squared, which is pi c squared over 4 pi squared, which is c squared over 4 pi. Does that look right? And that is area in terms of circumference.
Why would it be squared instead of times 2?
What?
Oh my gosh, wait, never mind, sorry.
Yes.
So if you're writing it in terms of radius, would it be, which one would it be? R equals D over 2?
This is the formula in terms of radius. Look, Tess, what's your variable here? Radius. What's your variable here? Diameter. What's your variable here? Circumference. All right, one leg of a right triangle is twice as long as the other. Now remember, the legs are the perpendicular sides. So if one leg is twice as long as the other, I might call them x and 2x. Now I gotta be careful here. X is the shorter leg, so I'm good, because it says find the hypotenuse in terms of x, the shorter leg. Well, what do you think?
You can use the Pythagorean Theorem.
Absolutely. When you see a right triangle, first thing that pops into your head is the Pythagorean Theorem, right? The second thing that pops in your head is SOHCAHTOA, right triangle trigonometry. But Pythagorean Theorem is always there. So x squared plus 2x squared equals h squared. So x squared plus 4x squared equals h squared. So 5x squared equals h squared. And what does h equal? Because I'm supposed to write the hypotenuse in terms of x. So I'm going to have to square root. So what is h going to equal?
5x.
Be careful. X root 5, isn't it? algebra situation, when I did this square rooting, I would do plus or minus, but not this time because it has a geometric meaning, right? So it's just the positive. The height of a right circular cylinder equals its diameter. So we all know what a right circular cylinder is. And the height equals its diameter. Write the volume of the cylinder as a function of its radius. What's the formula for the volume of a cylinder? Let's start with that.
Base
Pi r squared, that's base,
times 5.
times height, right? Pi r squared h.
On the test, will we get these formulas?
No. These are ones you should know. Now, if it's something weird and random, then yeah. But no, you should know this. Okay. This is the formula for volume in terms of radius and height. We need to be only in terms of radius, which means we have to get rid of this. That has to go. So think about what they told you in the problem. Emma?
Wouldn't it just be height divided by 2? Because height equals diameter.
So wouldn't radius be height divided by 2?
Yeah.
Okay. Do I want to get rid of the radius? Do I want to substitute in?
Or are you trying to find diameter? Oh, no, it's trying to be radius.
I'm trying to do it in terms of radius, which means I want to go the other way, Emma. H is what? Isn't H 2R? And that's what I'm going to plug in right here. Because then I will be only in terms of R, which is what the problem said. Write, I gotta put it on in here. Write volume in terms of radius. Now, could we have done what Emma said and write volume in terms of height? Yes, she could take out the R and put in something in its place, but that isn't what we're supposed to do with this particular problem. So this is the volume formula in terms of radius. Now, please don't think that this is something you're going to memorize and use, because what was this predicated upon? What was special about this cylinder?
That the diameter
The
equals the
diameter
height.
is the same as the height, which isn't the case all the time. This is the formula if the diameter happens to be the same as the height. A sphere is contained in a cube tangent to all 6 faces. I have no way, I mean, I'm not a very good drawer, so I'm looking at it from the side view. This is what it looks like from the side. The ball is inside the box, tangent to all 6 faces. Find the surface area of the cube as a function of the radius of the sphere. Is that the radius of the sphere?
Yes.
Yeah.
So what's this then? 2R? So what's the surface area of the cube? So this is one face of the cube. What's the area of this? The area of this square right here? 2R squared, or 4R squared? How many faces does a cube have? 6. So the surface area of the whole cube would be 24R squared? Done. Easy. That's the surface area of the cube as a function of the radius. Lynn?
When it says that the sphere is tangent to all 6 faces,
That means the distance across the sphere is the same as the distance across the box.
Okay.
All right, an isosceles triangle has its base along the x-axis with one base vertex at the origin and a vertex in the first quadrant. And its vertex.
wait, did we
And
still
the-
miss
I think you
four?
skipped one.
I think you skipped one.
Okay, well, I'm doing this one since I've already started it. I'll come back to it. All right, so an isosceles triangle has its base along the x-axis. On the, okay. Okay. So, what shape is that? Y equals 6 minus x squared. What shape is that? Parabola
Upside
opening down, 6 units up.
Yeah.
So it's gonna look like this. So this isosceles triangle is built like this. It has one vertex, one base vertex at the origin, and its vertex on the parabola. Okay? Like the area of the triangle, okay, let's start with that. What's the formula for the area of a triangle?
1/2 base
One
times height.
half base times height. So this right here would be height, and this right here would be base, right? Find the area of the triangle as a function of the length of the base. So this is going to become x. Tell me about the height.
6.
It's what?
Wait, no, it's not.
Not quite.
Yeah, it wouldn't be 6. It would be 6 if I were
Yeah.
here.
Well, we know that
Well, we know it's less than 6, yeah, okay.
they have two sides that are congruent with the isosceles triangle.
Well, we could,
Could you treat them as right triangles and then find base?
Well, let's think about this for a second. This equation right here is y equals 6 minus x squared. So if let's say I wanted to know this point right here, where x is 1. How would I find that point if I knew x was 1? Wouldn't I just plug it in? Okay, well, what is this x coordinate for this point right here? Watch it now. What is that x coordinate?
how would we know?
Isn't it half x? This is x, right? Isn't that half of x? So the x coordinate of that point is half x. How did you tell me I was gonna find the y? Plug it in. So my y coordinate is 6 minus 1/2 x squared. So that y coordinate is going to be 6 minus 1/4 x squared. Which means, what's the height of my triangle? Isn't my height the y coordinate?
Yeah.
So my height is 6 minus 1/4 x squared.
Do you have to divide by?
What?
Do you need to divide by 2 at the end?
Divide what by 2?
The area?
No, you should 1/2.
I use 1/2 base times height. It's just 1/2 base times height.
Oh yeah.
So my base is x, my height is that, so my area will be 3x minus 1/8 x cubed. Whew, there it is. There's the area for this particular problem. Lucy?
I'm confused on how you knew that the height was going to be the y coordinate. Yeah. I think that you did.
Okay, I don't even know how to explain that. This point is x comma y, right?
Yeah.
Right? How high is that point? I went over this far and up this far, so how far up did I go? Did I go up y?
Yeah.
Whatever y is, and in this problem, y turned out to be this.
Okay.
So that's my height. Yeah, you guys need to think a little bit now. You can do this. But it's not all cookie cutter, it's not all gonna be exactly the same. All right, let's try the one I skipped. A square is inscribed in a circle. Write the area of the square as a function of the radius of the circle. Okay, so the radius looks like this. Be careful. Doesn't the radius look like that? The area of that square is going to be side squared, so I really need to know what this is. I can do this a couple of different ways. So
Does that
one
make a
way, can I
right
make that little triangle right there?
Yeah.
And then can I find this side right here doing the Pythagorean theorem? Or if you happen to remember your 45, 45, 90 ratios, you can do that too. So this is S. So r squared plus r squared equals s squared. So doesn't 2r squared equal s squared? And we need s squared, so isn't that just 2r squared? That's s squared, my area. That's s squared. Easy. Easy. The base of an isosceles triangle is half as long. So the base is half as long as the two equal sides. So the two equal sides would be 2x. Would you agree with that?
Yep.
Write the area of the triangle as a function of the base. All right. So 1/2 base times height. My base is x. Here's my height.
Could you do the Pythagorean theorem?
Absolutely. Don't we have a right triangle sitting right there, guys? Now be careful, because if you're doing the Pythagorean theorem, you're not using x, you're using half of x. So 1/2 x squared plus h squared equals 2x squared. So I'm solving for h. So let's see, x squared over 4 plus h squared equals 4x squared. H squared equals what? What's 4 minus a 4? 15 fourths.
15 fourths. Square root of 15 over 2.
Perfect, yep, that's your height. Square root both sides, that's your height. So that's what I'm gonna put in my formula. So I have 1/2 x, root 15 over 2x. So what's the area of that triangle gonna be? 1/4 actually, root 15 over 4 x squared. care of that section. Interesting. Tess?
I'm figuring out x squared over 4.
Got what?
X squared over 4.
The base is 1/2 x. I square it. 1/2 squared is 1/4. X squared is x squared. Right?
For the side lengths, instead of 2x, 2x, and x, can you run x, x, and then 1/2 x if you wanted to?
No, because you have to express your area, your area in terms of the base length. So the base
Oh, so
length
it
has to be a
x.
variable.
Okay.
Now, otherwise you could. If it didn't
Yeah.
say that, yes, that would be fine.
Okay.
But you have to do it in terms of the variable they tell you. All right. Next. How many rotations does a 15-inch radius tire make per second on a sport utility vehicle traveling 70 miles an hour? This is kind of like one of those chemistry problems. Back when I was a kid, we called them factor label. I think they got some fancy name like stoichiometry or something weird like that. We're just changing from one reference to another. So we're starting with 70 miles per 1 hour. That's what we're starting with. And we're gonna do a bunch of stuff. And eventually, we want to end up with revolutions per second. A rotation is the same as a revolution, so you can, whatever words you want. Okay? So we got to get from that to that. Now, for me, the time is always the easiest. I can do time. I have hours. I want seconds, so I'm gonna multiply this by 1 hour per 60 minutes. Now, why did I put my hour on top? I need to cancel them, so you've done this before. And then I need seconds, so I'm gonna say 1 minute, 60 seconds. Everybody okay with that? Oops, I'll cross out the 60. Just minutes. All right. Now, I've got miles, and I need to get to revolutions. So a revolution is a circumference. So I'm going to say 1 revolution is 1 circumference. Now read the question. What is the circumference of this tire? 30 pi inches. So 1 revolution is 30 pi inches. Everybody okay? Now, I got my revolutions and I got my seconds. The problem is, these guys haven't canceled out yet, right? So I gotta get rid of them. So what do I know about inches? 12 inches make 1 foot. 5,280 feet make 1 mile. Okay, now wait a minute. Is that gonna take care of it for me? Am I okay now? So the only units left are revolutions per second, which is what I want. So now I'm gonna get my calculator out. So on top I have 70 times 12 times 5280. Is that it on the top? Okay. Now, I got a top number there, it's a big number, that's my top. I'm gonna go ahead and just start dividing. You can go ahead and do your denominator all at once, and then do your top divided by your bottom, if that is easier for you. I'm just gonna do divided by 60, and then divided by another 60, and then divided by, be careful, parentheses, 30 pi. What happens if you don't put the parentheses in there? It divides by 30 and times us by pi. If you want it to divide by both, you have to tell it to divide by both. I ended up with 13.07, but I was talking and not paying much attention. Anybody else get 13.07?
Yeah, I did.
So what's the answer to the question? About 13 revolutions per second. That's how fast this wheel is spinning. All right, so that looks vaguely familiar to you in terms of stuff you learned how to do before. All right, key there is what Peter said. A revolution is a circumference. So you gotta make that key and then you're ready to go. All right, back in your seats at 49 in our seats, ready to go. 49, 439, I don't care.
Ooh, should I consider that?